right, so we're going to go over number 3. Person scuffing her feet on the wool rug. Guys, remember, if you don't need this one, don't feel like you have to follow along, but do keep it down quiet enough that I can hear myself trying to think through the problem, okay? Alright, how many excess electrons does this person get? I would say the starting point in your Y on this would definitely have to be that electrons have one quanta of negative charge. Because if you don't remember that fact, you're not going to go far in solving this problem. And then, let's see. That's basically it. That would be all you would need for your Y on this one. That's the only understanding you really need for the Y side of it. If we look at our equation sheet here, equation-wise, this is about something having a net charge, so I'm going to look in the charges box, the L-shaped box over there on the left, and I have that the net charge on something is n, the number of charges times the value of each charge. Since I already stated that electrons have one quanta of charge, I know that in this case, the E is a quanta. Again, referencing my reference sheets, I go to the constants values, and down here at the bottom, I know that a quanta of charge is 1.602 times 10 to the minus 19th coulombs. So, I'm told I need a total of, let's see, negative 77 microcoulombs, so I know that's going to be made up of electrons. So I can just use the 77 times 10 to the minus 6 coulombs equals n times 1.602 times 10 to the minus 19th coulombs. I could use negative values for each of those, but I'm really worried about the net charge. Solve for n. And then the second part of the question asks me how much mass. It says how much mass do we gain? How much does our mass increase? Well, back on my equation sheet, I know that each electron has a mass of 9.11 times 10 to the minus 31st kilograms. So her total mass is going to be the number of electrons times the mass of each electron. So whatever my answer for n is before times 9.11 times 10 to the minus 31st kilograms for each electron. And I'll get the total mass that she increases by. Yep, that'll do it. Alright. Alright, so we're going to do number 1 now, where it asks you to calculate the magnitude of force between 3.2 times microcoulomb point charges that are 7.1 centimeters apart. Right away, I bet some people stumbled in the not looking at the units, not looking at that it was microcoulombs and that it was centimeters, because that will throw the magnitude of your answer off. So this is number 1. Like charges means same type. Repel each other. And probably all you really need in your Y, except it is talking about forces, so this is when you would need a force diagram on. So you would have a charge here, and a charge here, and there would be a force electric here, and a force electric here. And my guess is they meant for them to be fixed, so that's really all you would need for your force diagram. Alright. So on to the how side. We have two charges. There's a force between them. If I look at my equation sheet and I look in charges, Coulomb's law there, F equals K, Q1, Q2 over R squared, describes the forces between two charged bodies. So that's where I'm going to start. F equals K, Q1, Q2 over R squared. Might mention in your Y, you don't have to, that the forces on each are the same. Either way. So now I know K from my equation sheet. The back of that rubric has my facts and constants again. And I have Coulomb's constant down here, 8.988 times 10 to the 9th Newton meter squared per Coulomb squared. So that right away, since I've got that in newtons, meters, and coulombs, tells me I need to make sure that if I have charges in my equation, they're coulombs. If I have distances, they're in meters. So substituting in now, 8.988 times 10 to the 9th Newton meters squared per Coulomb squared. Up top, the charges involved. I have two of them, so 3.2 microcoulombs. So I'm going to do 3.2 times 10 to the minus 6 coulombs. Since I have two identical charges, those two multiplied together is the same as squaring that. And then the distance apart, 7.1 centimeters is 0.071 meters. And I square that. And I have all numbers on one side and the variable that I want to solve for on the other. Alright, so number 6 was the next one asked for. We have a proton, it's released in an electric field, experiences this much force towards the south, and they want to know the magnitude and direction of the electric field. Right off, probably your first good statement would be that a proton has one quanta of positive charge. And then an electric field, the next thing I would make sure I had in there showing my understanding of an electric field, it is an area where a charged object or body feels a force and the electric field points in the direction a positive charge feels a force. So you are showing your understanding of both an electric field and a proton. Is that a complete Y? No. Because the question mentions forces. So what do you have to have? A force diagram. Gotta make sure you look at the problem and you evaluate which rubric is going to be used on your Y, because you don't want to give away half the points. So a force diagram here Experiencing force this towards the south. Okay. So I've got my proton here. It has a force on it in that direction. And that would mean that I would have an electric field shown by these black lines. Also towards the south, and I would label those E. I might move this one. Move this. There we go. So that would be my force diagram there, where the electric field and the force are pointing in the same direction. So, I jump to my equation sheet, and I say, okay, I'm talking about an electric field and a particle feeling a force in that field. In my area about electric fields, I have one that describes the field that's created by a charge, and one that describes the field because a charge in it feels a force. So that's the one I'm going to use. The right-hand one is about, hey, the electric field causes a force on a charged object. So I'm going to use that the electric field strength is the force on a charged object. And I know the force, 6.1 times 10 to the minus 14 newtons. I know the charge because, as I said in my Y, it's 1 quanta. And I know from my facts that 1 quanta is 1.602 times 10 to the minus 19. So I have that the electric field is 6.0 times 10 to the negative 14 newtons, and it's on 1 quanta, so 1.602 times 10 to the minus 19 coulombs. And I find how strong my electric field is. It ends at 9:02.